Hello, everyone. In this video, I will answer some of you asked question about week 4 worksheet assignments. I was asked to show where to find the lab experience 10 exercise. And in week 4 worksheet assignment, we also have unit 7 lab experience 11 exercise. I'd like to show you where to find them. Unit 6 and Unit 7 lab experiences 10 and 11 are both in Syncage Man tab. So we need to go to Man tab. In Unit 6 lab experience, the first part is the background of assembly language programming. As you should have learned that assembly language is actually a set of mnemonics of the machine code of a computer. As you have learned that computers consist of logic circuits or digital circuits, and the digital circuits uses and implement only levels of the electricity, 0 or 1, so that our computer CPU consists of a set of binary operation code. They are listed in figure 10.1 in our textbook. The left column lists the machine code implemented in the CPU wires. And for each of the machine code, we use a mnemonic to help us memorize what the machine code is. The mnemonic is understandable by the people. So for 000, the mnemonic or the assembly code is load X. X means a memory location. In a specific instruction, the X might be given a known location in the memory. Generally, we don't know, so we use X to represent memory address. So 000, this machine code means load the value or data in memory X to the CPU. Okay, and its meaning is the content of memory X moved to register R, that is in CPU. Okay, the second instruction 0001 means store X. The meaning is store the value in register R to the content of memory at X. All right, and so on. So this table, figure 10.1, lists all the machine code in our CPU and the mnemonics in the middle column. The red column is a list of the meanings of the instructions to help us understand what the meaning of each of the instruction is. Okay. Now, let's go to the lab experience 10. It's here. Click this. Start assignment now, and you will see the assignment. Okay. So, like for the first one, number 1 is adding 2 numbers and display the result. All right. It asks you to use the assembler. Use the assembler to open a sample file. The sample file consists of the assembly language code. All right. So how to do that? Let me show you. Like when we come to the lab software, click the assembler, and then you can see here is the assembler animator. And we need to open the file. You need to go to the location where you installed the lab software. Okay. And go to the lab software, open the examples, it asks you to open the example 1.asm. ASM means assembly code. So open example 1. This is the assembly program for the computer, as listed like here in the assignment. And you should be able to understand what this means, right? The assembly language start with dot begin, end with dot end. And then it load X, means load the value from memory address X to register R. All right. If you don't remember all the instructions, you can click to view the instruction set. All right. The instruction set is exactly as we just saw in the textbook. So you should be able to understand what they mean, right? Add one, you find here, add y is add the value from memory address X. Here is from memory address Y to register R. And then store the value in register R to memory address Z, and then output Z, and then hot. This is the end of the program, the end of the program. Now, after the end of the program hot, we store the data, store some data values. So at X, that is memory address X, we store data value 2. At memory address Y, store data value 4. At memory address Z, store data 0. So this is the entire assembly language, and the purpose is to add the value at memory address X and the value at memory address Y, add up them, and then store to memory address Z, and then output. That's all. That's what the program do, right? And then what you need to do, following the instruction, you just say, all right, let's close this. You need to assemble, and after you assemble this, you can see it scan the assembly code and try to find if there's any error. Here shows no error. And it also assign the line numbers to each of the line. Okay, so this is actually showing us how each of the lines stored in the memory, right? Here it shows that stored from the beginning of the memory, and each of the other lines just follow the first one, so that is stored in the beginning of the memory address, all right? So this is about the program, and then it may you may see object code. The object code is the machine code. Okay, we should understand now each of the machine code, machine instruction consists of 16 bits. The first 4 bits is the instruction code as we showing in the instruction set here, right? Like 00040 is actually we just saw that is load X, right? And load from where? The remaining 12 bits is the memory address. So this is actually 5. That means load the value at memory address 5 to register R. So this is the first instruction meaning. Anyway, you can explain the meaning of each of the instructions. So this is the machine code of the assembly program. Assembly program is much easier to understand, right? Okay, so this is what you need to do. All right, what you need to do. Yeah, you may want to say the symbol. The symbol is to show us where each of the symbol is stored. That is the address of the symbol. Like X is at address 5. 5, Y is at address 6, Z is at address 7, right? So this is what you can see. Now you are asked to execute the program. So you click execute. It will show the Von Neumann machine. We have learned Von Neumann machine, right? Von Neumann machine have the memory address and CPU integrated in a single unit uh, of computer, and that is called CPU. And Von Neumann machine shows us all the registers inside the CPU and all the memory combined with the CPU. And here show the source code. That is the assembly code. Okay. If we execute, that is to run, you should be able to find the output here. It comes to halt, right? So you can watch, observe the execution of the program and try to understand everything in the Von Neumann machine and also in the assembler. So this is what you need to do about lab exercise 10 in unit 6. All right. Now for lab experience 11, this is about using network. And you need to destroy a packet, damage a packet, spying on the network. And also, we following the instruction, we will use network simulator. And you open the network simulator, and here is where you enter the original code, the plain text. For example, enter my name and click prepare. It will encode the characters I entered, and here has the binary code, and then it encrypted the binary code in this row, and then it creates the packets in this row, and then these packets, encrypted packets, will be sent through the network and go to the receiver side. And we can see, like, if you click this, you will see one, actually 0 packets is put on the network, right? And you can continue to move. And then the second move to here, the first one here, if you just continue to move, finally the 4 packets will be moved to the other side. If you click check, every packet is okay, that means fine. Now, so you can receive them, so that you receive the original characters. So this is how the network is transmitting the data. But suppose now we do it again. Create a new one. Suppose somewhere we send, and suppose somewhere we damage one, like this one damages, and we continue to move. If we check, it says this is not okay, right? So we need to fix it. Click the fix it. All right, it will resend the packet and move again, and then you check again, and everything is okay. That is all. And similarly, you can use like destroy and see what happened. And finally, you may need to spy and see what you can see. Spy, is just to somebody like a hacker can intercept your data and can view the data. And you will see that if the hacker can see the plain text or just the encrypted text, and you will figure out what the hacker can do, something like that. So this is about using the network simulator for lab experience 11 in Unit 7. So that's it. Hope this helps you.